Hello everybody! Today we will make a $1 fan sink for our Raspberry Pi to keep it cool. In this video, we will show other available cooling options and compare them to our simple fan sink. This should help you in making the right choice of the heatsink to run your Raspberry Pi full-time 24x7. This is the CPU of our Raspberry Pi. It came with a tiny copper heatsink over it, which is not doing a great job in keeping it cool. In order to check the reason, we will use a few monitoring tools. Our operating system is Ubuntu Mate. We will add CPU frequency scaling monitor, which will tell us the frequency that our processor is operating at. Hardware sensors monitor to see the processor temperature live, and system monitor to check the processor usage as a graph. In order to stress the processor to 100%, we can use a program called Stress, but a simple way is to run YouTube at higher than playable resolution, and it should occupy the processor to its maximum. We can choose any browser for the task, but in this case we are using Chromium. Opening up YouTube in the browser should increase the processor activity, which we can see at the top of the screen. Also, we can see that the temperature is climbing rapidly. As we can see in the processor graph, it is only operating at 50% of its capacity. Let us increase the YouTube video resolution to 1440p. Quite instantly, we see that the processor is 100% occupied. Also, the temperature quickly reaches 80 degrees and the processor starts throttling, meaning it is lowering down the frequency to save it from damage. Although it will continue to work, the problem is that we now have a computer that works slower than intended. So, it is better that we use some sort of cooling solution for our Raspberry Pi to make it work at full capacity. Just to note, all this is happening at the base frequency of 1.5 GHz and it is not even overclocked yet. We will shut the Pi off and try the thermal control solutions, but we will do it step by step to gauge how well each of them work. We will fix a heatsink to our Raspberry Pi's processor. As we can see, the heatsink already comes with a thermal pad along with the adhesive. All that we need to do is to peel off the protective layer and stick it right in the center of the processor. There are quite a number of heatsinks that are available in the market, a few of them that are tall and will not fit in the standard case of the Pi. Others are bulky and cover the entire Pi but also block its Wi-Fi range. Then there are the extreme solutions that are outrageously expensive, costing as much as the Raspberry Pi itself. We booted up the Pi with the new heatsink. We observed that the no-load temperature is quite less than before. Let's start the load test by opening YouTube again. As we can see, the temperature sure is increasing, but the rate at which it is climbing is slower than before. Looks like the heatsink will absorb the heat because of its bulk, but eventually will get to the 80 degrees unless the heat is dissipated using air circulation. Mind you, we still haven't overclocked it. Let's add the next upgrade to the cooling system. Nope, it is definitely not what I'm doing right now. This will surely keep the Pi cool, but also damage it over a period of time due to moisture. We will fix this tiny fan to the top of the Pi's case cover. Remember why we chose a smaller heatsink earlier? It is to have the necessary space to fit this fan inside the case. The fan works on 5 volts and we can power it from the general purpose input-output pins, also called as the GPIO pins on the Raspberry Pi. As we can see here, these pins have 5 volt and ground, which is suitable for the purpose. We will plug the red wire into the 5 volt pin and the black wire into the ground pin. Let us test it now. Quite instantly, we see that our Pi's ideal temperature is much lesser than before. When subjected to load, we observe that the temperature does not increase as much. But as we can see, it is still not able to play the 1440p video comfortably. Since we now have a cooling system that will make sure our Pi will not get to 80 degrees even under full load, let's overclock the Pi to make it run quicker. Overclocking Raspberry Pi 4 is worth it because we can extract 25% more performance without any harm to the unit. It is also very simple to do. Just including these 4 lines in the right file and rebooting it will do the job. Here we overclocked our Pi to 2 GHz. After the reboot, we see that the settings are applied and we now have a 2 GHz option in our frequency scaling monitor. We will start off the test by setting it to the maximum frequency. Our video is playing smoother than before. Running the test over an extended period of time has increased the temperature to 72 degrees, where it is stabilized. This looks like a good cooling solution for our Pi, since it will not get to 80 degrees and throttle. There is one problem though. These tiny fans run well for short periods of time but fail quickly. Either they collect dust and slow down considerably, or they start rattling and become noisy. Running them 24/7, we found out that they last a couple of months maximum, which is why we need a better solution. Here, we will use an inexpensive 80mm DC fan that we bought for $1. It is similar to the ones that we use in our desktops. Since the fan works with 12 volts only, and because the GPIO pins cannot output 12 volts, we will use an external 12 volt adapter to power the fan. We connected the red wire of the fan to the positive and the black wire to the negative of the adapter. We will tape these wires later so as to not short them. Now we fix 3-inch screws using the bolts to the mounting holes on the fan and tighten them using a screwdriver. This way we created a simple standoff using which we can place the fan sink over the Raspberry Pi. Wow, it looks awesome. Let's see how well it works. The ideal temperature is low as expected, and at load we observed a maximum temperature of 67 degrees, 5 degrees less than the smaller fan could manage. What's better is that since the diameter of the fan is larger, we are cooling not just the processor of the Raspberry Pi but also the other components on the board. By placing it a couple of inches high above the board, the wind noise is much lesser than compared to earlier. This is the ideal cooler for a Raspberry Pi, and we have been using it 24/7 for well over a year. It is not ultra portable though, so you can use the smaller fan when you need portability, but for running it full time at your desk, you can use the bigger fan. If you do not like the fan's LED lights, you can use a fan without them, and it will work just as good. What more, it will cost you $1 in all. Speaking of things that can be done with $1, you can get fantastic web pages for $1 at our website $1site.com. The service is simple. You select the images, give the text, we will build a great looking website for you and host it on our servers. It will not just be any other ordinary website, but in fact, your website will be among the quickest in the world, right at the top. Quick enough to load in half a second, not just in one place on the map, but around the world. We know it is hard to believe that you can get such speed for $1, but hey, why not test the speed of $1site.com to cross-check what we said. The speed test link is in the description of this video. You might as well do a live test and compare it with any other website that you think is faster than us. Of course, compare it with pages of similar size to keep it fair. We bet you will not find many that are quicker, and if you happen to find any, let us know in the comments below. We are confident that this video will have no comments with the names of other websites. Thank you and have a wonderful time. This is Arjun and Vishnu signing off.